Hello my friends, and welcome back to the You Can Do TV channel. In large-scale pipeline construction, every tube follows a precisely coordinated logistical and engineering sequence. After production, each steel pipe section is transported by rail using specialized cradle racks designed to prevent ovality and surface damage. Upon arrival at the staging site, dedicated hydraulic pipe handling machines unload the tubes, lifting them with synchronized grapple arms that maintain controlled balance to protect the bevel ends. The pipes are then placed on support beds for dimensional inspection, ultrasonic testing, and verification of wall thickness before assembly. Once quality checks are complete, alignment crews use internal lineup clamps and laser-guided positioning tools to ensure that each joint meets straightness and gap tolerances. Automatic and semi-automatic welding systems, often multi-pass MIG, FCAW, or SAW processes, are used to create high-strength girth welds, followed by real-time radiography or phased-array ultrasonic inspection to confirm weld integrity. At the drilling sites, the pipe string is further extended and connected to a drill head or casing shoe, depending on the application. The assembled pipeline sections are then transported by side boom crawlers or pipe carriers to directional drilling rigs or open-cut trenches. Each completed string is lowered into position, supported by padded slings to avoid coating damage, and prepared for installation into the ground. Octal Steel manufactures API 5L seamless steel pipes using an advanced hot rolling process designed for high strength and flawless structural integrity. Billets are heated, pierced, and elongated through precision rolling mills, followed by online furnace treatment to refine grain structure and enhance toughness. Dimensional accuracy is maintained through continuous gauge control, ensuring tight tolerances for demanding pipeline installations. Supported by extensive inventory and engineering expertise, Octal delivers pipes capable of withstanding extreme pressure and temperature, offering superior corrosion resistance and uniform mechanical performance with no weld line weaknesses. Fully certified to API 5L and ISO standards, these seamless pipes provide long service life and are widely deployed in oil, gas, petrochemical, and power generation applications. The production flow at Alpena Tubulars in Nittelfeld, Austria, transforms solid steel billets into high-performance seamless pipes through a tightly controlled sequence of thermomechanical forming and heat treatment operations. Manufacturing begins with continuously cast round billets, 230 mm in diameter, supplied by a highly advanced steel plant within the Alpena Group. These billets are cut to required lengths using high-precision carbide-tipped saws. A smaller portion passes through a preheating furnace before shearing. All billets then enter an automated rotary hearth furnace, where they are uniformly reheated to approximately 1,280 degrees C to reach forming temperature. Shaping into tube shells starts at the cross-roll piercing mill, where angularly set rolls drive the hot billet over an internal piercer at roughly 1 meter per second, producing a seamless hollow shell. A mandrel bar is inserted, and the shell is elongated up to 17 times its original length through the push bench forming rolls, creating a hollow up to 22 meters long with minimum wall thickness near 3 millimeters. An expanding section removes the mandrel before the hollow undergoes radiometric wall thickness measurement for dimensional control. The hollows then enter a computer-controlled walking beam furnace, rotating continuously to ensure uniform reheating prior to stretch reducing. The 28-stand stretch reducing mill imparts the tube's final diameter and wall geometry. A second radiometric inspection verifies dimensional accuracy and directly feeds process control systems. Depending on mechanical requirements, tubes up to 150 meters long are then rapidly cooled to achieve specific metallurgical properties before being cut to final or multiple lengths. These tubes may proceed to other forming facilities or serve as pre-material for automotive, boiler, mechanical, or oil and gas applications. For OCTG and drill pipe production, pipe ends can be upset according to API specifications or shaped into premium connection geometries using induction heaters and mechanical or hydraulic upsetters. In the austenitizing furnace, pipes are reheated so their microstructure transforms, enabling controlled quenching. Rapid cooling generates a hardened matrix, which is subsequently tempered at precisely regulated temperatures and dwell times to achieve the required steel grade. After heat treatment, rotary straightening machines restore tight linear tolerances. Quality assurance includes comprehensive, non-destructive testing. Electromagnetic inspection and phased array ultrasonic systems scan for longitudinal, transverse, and oblique flaws while mapping wall thickness and detecting laminations. Pipe ends are further assessed using UV magnetic particle inspection. OCTG threads are cut on CNC threading lines, and couplings, machined from seamless coupling stock, are threaded, phosphated, and installed with fully monitored makeup parameters. Hydrostatic testing then fills each tube with pressurized oil-water emulsion, verifying structural integrity. Threads receive corrosion-resistant grease and mechanical protectors. Finally, pipes are weighed, measured, stenciled with traceability data, bundled, and staged for global shipment, completing a fully integrated seamless pipe production flow engineered for high reliability and demanding service environments. ULA's Decatur, Alabama rocket production complex, spanning 1.6 million square feet, is a continuous flow aerospace manufacturing environment responsible for Atlas V, Delta IV Heavy, and Vulcan Centaur hardware. The process begins with raw aluminum plate entering double gantry CNC skin milling centers, where material is precisely machined to reduce weight by up to 70% while retaining critical structural strength. Machine panels are transferred to forming systems, including brake forming and bump presses, to generate the required curvature for fuel tank barrel sections. Corrosion protection is achieved through a controlled anodization line, where components undergo high-pressure washing and sequential chemical baths. Panels then enter the vertical friction stir welding cell. Here, a rotating pin tool generates frictional heat, plasticizing the metal and forging panels into seamless cylindrical tank structures. Completed barrels move to circumferential friction stir welding stations to integrate domes and finalize the Stage 1 tank assemblies. After structural pressure testing, tanks receive SOFI, spray-on foam insulation, to mitigate acoustic and thermal loads during ascent. Parallel production lines build Centaur upper stages using ultra-thin stainless steel pressure-stabilized tanks. Gores are precision welded to form bulkheads, while skins are joined via spot and seam welds before receiving SOFI for cryogenic protection. Final assembly integrates propulsion systems, avionics, pneumatics, and engine modules. Completed booster and upper stage structures undergo full system testing before being transported approximately 1 mile to the Tennessee River dock. Loaded onto ULA's RS rocket ship, each rocket begins its journey, an 8-day trip to Cape Canaveral or a 23-day deployment to Vandenberg, ready to support national security, planetary exploration, and deep space missions. Titan Steel Wheels Limited represents more than a century of engineering excellence, operating as one of the world's largest and most specialized manufacturers of off-highway wheel systems. The company's technical footprint spans earth-moving, construction, mining, and materials handling sectors, where wheel integrity directly influences equipment load capacity, cycle efficiency, and fleet reliability. Titan's approach begins with raw materials engineered in collaboration with supply chain partners to achieve controlled chemistry, superior weldability, and high fatigue performance under extreme duty cycles. All core engineering and manufacturing operations are consolidated under one roof, enabling seamless integration between design, prototyping, machining, forming, welding, heat treatment, finishing, and inspection. Design engineers work in close collaboration with OEMs and end users, translating field challenges such as dynamic loading, impact events, lateral stress, and thermal expansion into optimized wheel architectures. This includes tailored rim profiles, reinforced bead seats, precision machined mounting interfaces, and proprietary section geometries designed to withstand the specific load spectra of each application. Investment in advanced machinery and digital manufacturing systems ensures repeatability and dimensional accuracy. Automated forming cells, multi-axis CNC machining centers, and robotic welding platforms support tight tolerances and consistent structural performance. Quality assurance is applied at every stage through non-destructive testing, in-process measurement, and full metallurgical validation. Prototype wheels undergo rigorous structural and fatigue testing in Titan's engineering center, followed by validation in real-world operating conditions, ensuring each product meets or exceeds industry standards. The company's finishing systems deliver corrosion-resistant coatings, engineered for harsh mining and construction environments, extending wheel life and reducing maintenance cycles. Globally, Titan Steel Wheels is recognized for delivering high-performance solutions relied upon in major industrial projects, including demanding underground operations such as Cadia East. Despite its worldwide presence, Titan maintains a strong commitment to environmental stewardship, workplace safety, and long-term partnerships with customers and local communities. Through continuous innovation, disciplined engineering processes, and deep application expertise, Titan Steel Wheels Limited sets a benchmark for durability, reliability, and performance across the off-highway wheel industry. Bakri Pipe Industries is a leading producer of large-diameter steel pipes engineered for demanding oil, gas, and water transmission applications. Its manufacturing line integrates high-frequency ERW, spiral saw, and longitudinal saw technologies to accommodate a wide range of diameters, wall thicknesses, and steel grades. Incoming coils are straightened, edge-milled, and formed under controlled load to achieve precise roundness before welding. Automated seam welding, online ultrasonic testing, hydrostatic pressure testing, and robotic coating systems ensure each pipe meets stringent mechanical and corrosion resistance requirements. With this fully integrated workflow, Valkyrie delivers pipeline products optimized for long-distance transport and critical infrastructure projects. The company manufactures 8 inches minus 63 steel rims in 3-piece tube/tubeless configurations and 5-piece assemblies for heavy mining trucks, construction machinery, port handlers, loaders, earth movers, and mobile cranes. Rims are formed from precision-rolled profiles produced in-house, ensuring uniform wall thickness, tight roundness tolerances, and high structural integrity. Advanced forming, flash butt welding, CNC machining, and heat treatment processes provide consistent bead seat geometry, superior fatigue resistance, and reliable air retention for tubeless systems. The cement mortar lining process begins once the steel pipe has passed hydrostatic testing. End dams are first installed on both ends to control material retention and ensure a uniform lining profile. Roundup rings are then positioned to maintain pipe roundness and structural stability during rotation. The cement mortar is mixed at a precise 2:1 sand-to-cement ratio, prepared in individual batches for each pipe, and loaded into a hopper for controlled delivery. The pipe is lowered onto the rotating belts, cleaned internally with a blower, and the lance is inserted to the far end. As the pipe spins, the lance retracts and deposits mortar evenly along the interior surface. Rotational speed is then increased to generate approximately 70 grams of centrifugal force, consolidating the lining and expelling excess water, which is subsequently removed by airflow. After initial set, the pipe is extracted without rolling, the roundup rings are removed, and the unit is transferred to the curing station. Steam curing at 90 degrees Celsius for 18 hours brings the lining to its required compressive strength before the pipe proceeds to external coating. Steel water pipe manufacturing begins with steel coil as the raw material. The coil is loaded onto the mill and flattened through a series of rolls to maintain straightness before entering the forming section. In this section, spiral welding occurs, starting with an inside diameter weld, followed by an outside diameter weld to achieve a complete joint penetration. The process uses submerged arc welding under a mantle of flux, ensuring consistent, high-quality welds. The continuous spiral pipe production allows theoretically infinite lengths, but a plasma torch cuts pipes to project-specified lengths while the pipe is being formed. After cutting, the pipes are transferred to an inspection station and then staged for further processing, including bell expansion. This highly automated process ensures precise dimensions, strong joints, and consistent production efficiency for steel water pipes. The manufacturer specializes in engineered wheel systems for mining, forestry, and heavy material handling fleets, leveraging a process rooted in precision fabrication. Roughly 90% of each wheel originates from flat steel plate, subsequently rolled, CNC machined, and fusion welded to form a high-strength, load-rated structure. Tight dimensional control ensures optimal concentricity, fatigue resistance, and compatibility with large off-highway tires. A new multi-operation machining center replaces 5 legacy stations, improving cycle time, accuracy, and process stability. The company also develops TireSense, an integrated temperature and pressure monitoring platform designed for extreme duty haulage applications. Engineering-led product refinement and long-term field partnerships position the firm as a technical leader in heavy equipment wheel manufacturing. The production of API 5L seamless steel pipes in China is a precise, step-by-step process designed to deliver high-quality, reliable products for the oil, gas, and industrial sectors. It all starts with molten steel in converters, refined in annular furnaces to achieve the perfect chemical composition and temperature. The steel is then cast into billets, ready for the piercing stage. Here, solid billets are transformed into hollow shells, which are fed into the pipe mill. In the mill, these shells are gradually stretched and sized to the exact diameter and wall thickness required. Once formed, the pipes are carefully cooled to reach the desired mechanical properties. Carbide-tipped saws then cut the pipes to specified lengths, and straightening machines ensure perfect alignment. Quality is critical at every step. Each pipe undergoes thorough visual inspection and advanced non-destructive testing, such as ultrasonic and magnetic particle checks, to detect any imperfections. Pipes are then marked with specifications and batch information before being securely packed for delivery. From raw steel to finished, precision-engineered pipes, every stage of this process is meticulously controlled, ensuring the seamless steel pipes meet strict API 5L standards for performance and durability. The Logica in-furnace camera system features a long lens that penetrates the reheating furnace's refractory wall, providing operators with a clear view of the interior. This real-time visibility allows for precise monitoring of the process and enables immediate corrective actions, improving efficiency, safety, and overall furnace operation control. GMP Italia reveals how an alloy wheel is born through a precise fusion of advanced technology and refined metallurgical craftsmanship. At the heart of the operation is a fully industrialized production environment shaped by lean production principles, enabling consistent quality, streamlined throughput, and optimized resource utilization. This balance between artisanal know-how and automated control forms the foundation of the company's Simply Perfect manufacturing philosophy. The process initiates in the casting areas, where molten aluminum alloys are prepared under tightly monitored thermal and chemical parameters to ensure structural integrity. Automated casting systems, distributed across multiple stations, inject the alloy into high-precision molds, creating the raw wheel form with repeatable dimensional accuracy. Each casting station is engineered to stabilize temperature, pressure, and cooling cycles, reducing internal stresses and minimizing porosity. Once cast, the wheels move through a sequence of machining and refinement operations. CNC machining cells define critical geometries, optimize weight distribution, and achieve high concentricity values essential for dynamic performance. Surface treatments, including heat stabilization, shot blasting, and finishing coats, enhance durability while delivering the aesthetic signature associated with GMP products. Quality assurance is embedded throughout all phases. Dimensional scanning, X-ray inspection, and mechanical testing confirm compliance with stringent performance standards. This integrated system enables GMP Italia to produce up to 200 wheels per day, combining efficiency with uncompromising precision. 58 Aluminium operates a highly controlled smelting line equipped with automated rotary electric melting furnaces designed for stable thermal efficiency and uniform alloy mixing. Incoming scrap is mechanically pre-cleaned, magnetically separated, and graded by alloy composition before entering the charge system. The rotary furnace performs continuous melting with controlled rotation speed, optimized refractory lining, and regulated oxygen levels to minimize dross formation. Molten aluminum is degassed, filtered through ceramic foam filters, and chemically adjusted to achieve precise alloy specifications. Casting is performed in temperature-controlled molds to ensure tight dimensional stability and uniform grain structure. The facility's laboratory conducts spectrographic analysis, tensile sampling, and hardness verification to confirm compliance with required metallurgical standards. The entire workflow ensures consistent production of high-quality ingots for demanding industrial applications. Metal Gießerei Mannheim GmbH operates as a fully integrated ferrous casting facility engineered around digital planning, advanced mold fabrication, controlled melting, and precision finishing. Customer requirements flow into a centralized production planning system, where logistics, machining constraints, and metallurgical specifications are reconciled through coordinated cross-departmental scheduling. CAD-based model construction converts 3D design data into CNC toolpaths, enabling high-accuracy pattern milling. For complex internal geometries, SPS-controlled core shooting machines produce dimensionally stable sand cores using automated dosing, compaction, and curing cycles. Material integrity begins with certified charge inputs supplied as pre-alloyed bars. Spectral analysis validates chemical composition before furnace charging. Melting operations are executed with strict thermal control, ensuring the target temperature and melt homogeneity before tapping. Liquid metal is transferred into pre-prepared molds, where controlled pouring profiles ensure proper filling, laminar flow, and defect-free solidification. After cooling, castings are shaken out and freed from sand mechanically, then directed into subsequent fettling operations. Larger components processed in cold resin hand molding follow identical metallurgical principles but allow significantly increased form sizes. An in-house shot blast line sized for heavy castings removes residue and prepares surfaces for downstream coating, including optional powder coating pre-treatment. Precision finishing integrates grinding, deburring, and dimensional refinement. Complex freeform contours are evaluated using 3D optical scanning, enabling direct comparison with nominal CAD geometry for tool wear assessment and deviation correction. Systematic quality assurance, with 100% visual checks and immediate feedback loops, ensures every casting meets structural, dimensional, and surface standards required by modern machining and assembly operations. Jansa Sanai, founded in 1977, initially specialized in agricultural wheel production, and has since expanded into manufacturing a comprehensive range of wheels for tractors, agricultural machinery, mining equipment, industrial vehicles, military vehicles, heavy-duty trucks, and light commercial vehicles. The company operates a 100,000 square meter production facility in Aydın, Turkey, which houses 9 advanced production lines and has a planned annual capacity of 2 million wheels. Approximately 80% of the production is exported to more than 85 countries worldwide, demonstrating Jansa's strong international presence. The company emphasizes strict adherence to quality management and environmental standards. Production processes are aligned with ISO 9001, ISO/Technical Specification 16949, ISO 14001, Occupational Health and Safety Assessment Series 18001, and ISO 50000 standards, ensuring environmental protection, resource efficiency, and employee safety. Welding processes are certified to ISO 3834 standards, guaranteeing precision and reliability in high-stress applications. Additional certifications, including Televisionsdienst and Department of Transportation approvals, further confirm the high performance and safety of Johnson wheels. Johnson's production integrates high technology and automation to improve efficiency, reduce operational costs, and maintain consistent quality across all product lines. In-house research and development laboratories support every stage of product development, from initial concept and three-dimensional design to prototype testing and final approval. The company manufactures over 300 wheel sizes and nearly 5,000 product types. Each wheel can be customized with more than 200 different top coat colors and is coated with a complete electrocoating layer for enhanced corrosion resistance. The production facility includes fully equipped tooling workshops, computer numerical control machines, and robotic systems, allowing for flexible and precise manufacturing. Johnson continuously optimizes production processes to meet customer requirements, focusing on durability, safety, and long-term reliability while maintaining global automotive industry standards. OTR China operates as a precision-driven rim and wheel manufacturer for off-road, mining, and heavy-duty applications, with engineering disciplines centered on material science, machining accuracy, and weld integrity. CNC plate benders shape rim sections to tight geometric tolerances, while high-precision CNC drilling delivers exact bolt circle diameters for optimal load transfer. Critical structural interfaces, including rim bases, bead seats, and mating surfaces, are machined to uniformity, minimizing stress concentrations during heavy impact and lateral loading. Automatic welding systems employ controlled parameters and certified wire, achieving 100% penetration on circumferential welds, aligned with pressure vessel-grade welding protocols. Submerged arc processes ensure consistent fusion and superior seam morphology, increasing fatigue resistance in harsh mining environments. Post-fabrication, components undergo multi-layer quality assurance, including dimensional checks, weld integrity verification, coating inspection, and mechanical property validation. Advanced paint spray systems and surface preparation guarantee corrosion-resistant finishes suitable for abrasive and chemical-exposed sites. Built on ISO 9001 to 2015 quality systems, the company provides high-reliability wheel solutions for mining trucks, construction fleets, industrial equipment, and agricultural machinery worldwide. Perfection in alloy wheel manufacturing is not just about machines. Human expertise remains essential. At GMP Italia, the final control phase ensures that every freshly painted wheel meets the highest standards of quality and aesthetics. Each alloy rim is carefully inspected by skilled technicians, supported by advanced optical instruments to detect any imperfections that might escape automated systems. This meticulous process guarantees uniform finish, precise dimensions, and flawless appearance across the entire production line. Once the wheels pass inspection, they are carefully packaged and prepared for shipment, ready to be installed on vehicles worldwide. By combining precision technology with human oversight, GMP Italia maintains its reputation for delivering alloy wheels that exemplify both engineering excellence and visual perfection. The production of tire and wheel assemblies is a precise and highly technical process, requiring both experience and advanced machinery to ensure safety, performance, and comfort. At an industrial scale, most of the assembly steps are automated, allowing for high-volume production while maintaining strict quality standards. The process begins with feeding the rim into the assembly machine and installing the valve. Next, the tire is positioned onto the rim, and both components are lubricated to facilitate a smooth fit. The tire is then inflated to the required pressure, forming a secure and precise mount. After assembly, the tire and wheel undergo a series of measurements and balancing procedures. These steps are critical to identify and correct any imbalances or deviations that could cause vibration, noise, or uneven wear during driving. High-precision instruments are used to assess the uniformity of both the tire and rim, ensuring the final assembly meets stringent quality criteria. Finally, the completed tire and wheel assembly is labeled and either stored or shipped directly to the automobile manufacturer's assembly line. These additional quality control measures not only enhance safety and ride comfort, but also extend the service life of the tires. Modern TWA production exemplifies the integration of automation, engineering expertise, and rigorous quality assurance to deliver reliable, high-performance products. OTR wheel inspection and repair follow a controlled, industry-standard process designed to keep heavy equipment operating safely under extreme mining and earth-moving conditions. Under Australian Standard 4457, every wheel begins its journey with high-impact shot peening, stripping away paint and corrosion to expose the true condition of the steel. Critical zones are then coated with contrast paint, allowing magnetic particle inspection to reveal even the smallest cracks or stress indicators. Any irregularities are marked, and structural welds undergo ultrasonic testing for deeper verification. Once the diagnostic phase is complete, a full technical report outlines wear patterns, structural defects, and the recommended course of action, whether repair or retirement. Damaged components are rebuilt or replaced to OEM specifications, restoring load-bearing integrity. The wheel is then protected with a direct-to-metal anti-corrosion coating to extend service life. Finally, each assembly receives a unique identification code, ensuring complete traceability and dependable performance in the field. Tire uniformity is critical for optimal performance and comfort in modern vehicles. Traditionally tested at 8 km per hour, such low-speed measurements fail to reflect real road conditions. Eurofit in Boblingen revolutionized this process with its high-speed tire uniformity machine, capable of testing tires at 120 km per hour directly on the assembly line. This advanced system detects vibration and noise sources that conventional methods would miss, ensuring smoother rides, reduced cabin noise, and enhanced driving comfort. Producing over 10,000 high-spec tire and wheel assemblies daily, Eurofit combines industrial efficiency with precise quality control, delivering superior performance for electric vehicles, SUVs, and premium cars. In a transport sector demanding higher endurance and lower operating costs, Goodyear advances commercial tire engineering with a focus on structural integrity and lifecycle performance. The S200 Plus represents the latest evolution, developed through controlled compound formulation and precision carcass construction. Its K-Max silica-based tread reduces rolling resistance while maintaining thermal stability under continuous load. A reinforced steel-aligned casing increases impact resilience and enhances retreadability, enabling multiple service cycles without compromising structural strength. Manufactured in Goodyear's high-automation facilities, the tire undergoes strict dimensional, compound, and uniformity inspections. Combined with standardized retreading process, the S200 Plus delivers optimized mileage, predictable wear behavior, and reduced cost per kilometer for modern truck and bus fleets. At GMP Italia's Fusion Laboratory, alloy wheel manufacturing begins with controlled low-pressure casting, a process engineered for structural integrity and material purity. Aluminum alloy ingots are melted in precision-regulated furnaces, where temperature stability ensures consistent metallurgical properties. The molten alloy is then transferred into sealed low-pressure die casting systems. By forcing the metal upward into the mold under calibrated pressure, the process eliminates turbulence, reduces porosity, and forms a dense, uniform wheel structure. Once the casting solidifies, each wheel is robotically extracted and routed through CNC machining centers. Here, automated lathes sculpt the rim profile, mill the hub interface, and establish exact geometric tolerances. Dimensional accuracy is verified through coordinate measuring machines and laser scanners that inspect surface flatness, concentricity, and spoke symmetry. GMP technicians then conduct X-ray analysis to detect internal defects before moving to shot blasting, pre-treatment, and multi-layer powder coating. The result is a wheel engineered for performance, durability, and unmistakable GMP craftsmanship. The Bailhack HP 1500S is engineered as a high-capacity railway snowblower built for extreme winter operations, combining powerful mechanical systems with advanced control architecture. Its upper module is mounted on a heavy-duty turntable, allowing rapid directional changes for continuous clearing. Driven by twin 500-horsepower blower engines, the machine ejects snow up to 40 meters, processing as much as 16,000 tons per hour. The scoop wheel housings integrate independently controlled hydraulic chutes, while the retractable stem halves extend clearing width from approximately 3,000 millimeters to 5,800 millimeters. Blower gear ratios are selectable: reduced speed for maximum throughput or increased speed for long-distance discharge. Operator access runs through a central aisle between dual diesel tanks and blower engines. The traction motor system is engineered for high efficiency, with all drivetrain functions governed by an integrated electrical control module that manages the Voith turbo transmission, retarder, anti-slip protection, and blower drive interlocks. A pneumatically activated, hydraulically reversible track plow is mounted beneath the rear overhang and can be configured in V-shape or side blade mode. Cab design emphasizes visibility and thermal comfort. Heated glazing, forward-tilted 14mm laminated windshields, and large rotating panes maintain clear sight lines in severe conditions. Dual driver stations allow full operation from either side, with all propulsion and blower controls consolidated across the cab-wide panel. The snowblower head is powered by a low-loss mechanical gear system with crankshaft offset, enabling power from both engines to drive one head half when required. Compact yet exceptionally powerful, the HP 1500S delivers maximum performance for hard railway snow clearing applications. Off-the-road tires are engineered for vehicles that operate regularly on severe and uneven terrain, such as mining, construction, and heavy industrial sites. These tires are designed to carry extremely high loads while maintaining structural stability under continuous stress, enabling equipment to function in environments where conventional truck tires would fail. The construction of OTR tires consists of multiple reinforced layers, including steel cords and high-strength synthetic fabrics, which provide load-bearing capability, impact resistance, and dimensional stability. Specialized rubber compounds are developed to achieve a balance between abrasion resistance, heat dissipation, cut resistance, and traction, depending on the application. All tires are periodically inspected, with complete lifecycle records maintained in EM-Track, supported by standardized training from recognized tire industry organizations. In quarrying operations, tires are exposed to sharp rocks, high abrasion, and frequent loading cycles over short-haul distances. Tire design for quarry applications emphasizes cut and chip resistance, reinforced sidewalls, and optimized tread patterns to reduce heat buildup and irregular wear. Proper inflation pressure, road maintenance, and load control are critical factors in extending tire service life and maintaining equipment availability in quarry environments. The LaRue D87 single-stage snowblower is engineered for extreme snow management, delivering high-velocity discharge performance capable of banking snow up to 100 feet. Its heavy-duty impeller system operates within a reinforced housing to maintain optimal airflow efficiency and material acceleration. A high-horsepower powertrain supplies continuous torque, ensuring stable throughput in dense, compacted snow conditions. The machine's rigid frame, hydraulically controlled chute, and precision feed geometry support consistent projection height and directional control. Designed for airports, municipalities, and large industrial sites, the D87 provides reliable, high-capacity clearing with minimal operational downtime. The LaRue D97 single-stage snowblowers deliver commanding performance inside dedicated snow dump sites, where constant throughput and long-range projection are essential. Powered by a high-output engine, the D97 drives a large-diameter impeller that accelerates and expels snow in a continuous, uninterrupted stream. Its reinforced intake geometry feeds heavy, compacted material efficiently, while the hydraulically adjustable chute provides precise discharge control, even under extreme load. Built on a robust industrial frame, the D97 maintains stability and smooth operation across uneven dump site terrain. Engineered for demanding municipal and commercial workflows, it ensures rapid, high-volume snow relocation with professional reliability. The LaRue R36 heavy-duty tractor-mounted snowblower delivers efficient truck loading when paired with a John Deere 8360R. Its high-capacity impeller and wide intake housing pull in dense, accumulated snow with consistent flow, while the hydraulic chute provides accurate placement into haul trucks. The R36's rugged construction and optimized driveline ensure steady performance under sustained load. Built strong yet surprisingly agile, the R36 brings a reassuring capability to tough winter conditions, making demanding cleanup feel efficient, balanced, and remarkably manageable. The Bailhack 5012 railway snowblower at Fince demonstrates precise maneuverability, with its turntable allowing the upper blower section to rotate efficiently. Designed for harsh winter conditions, it delivers reliable snow clearing, ensuring safe and unobstructed rail operations while maintaining high performance and operator control in challenging environments. The Bilhack X 491.003 high-performance rotary snowblower delivers exceptional clearing capability for heavy winter operations. Weighing 77 tons, it integrates dual 1000 HP power units that drive a rotary system capable of removing up to 15,000 tons of snow per hour. Its self-propelled travel speed of 100 kilometers per hour enables rapid deployment across the network. Engineered for nationwide flexibility, the X 491.003 combines robust chassis construction, the LaRue D97 single-stage snowblower, paired with the Vancer CHX35 high-rail excavator, delivers a high-capacity, rail-ready snow removal system built for extreme winter service. With an intake width of approximately 96 inches and a processing capacity exceeding 3,000 tons of snow per hour, the D97 uses a high-efficiency single-stage impeller capable of projecting snow up to 120 feet under optimal conditions. Its reinforced housing and abrasion-resistant liners ensure reliable operation against dense, compacted or iced material commonly found along rail corridors. Mounted on the CHX35, the system benefits from the excavator's 70 to 80 kW hydraulic output, enabling stable impeller speed and consistent feed performance. The high rail gear allows smooth transitions between roadway and track, supporting precise positioning at switches, platforms, and yard infrastructure. A hydraulically controlled chute with adjustable rotation provides accurate discharge into trucks or containment areas, minimizing cleanup time. Inside the cab, operators access integrated controls for blower height, hydraulic flow, chute direction, and engine load monitoring. This coordination ensures efficient operation even during prolonged high-demand cycles. Engineered for power, reach, and versatility, the D97 CHX35 configuration offers a dependable, high-performance solution for maintaining safe and operational railway networks in severe winter conditions. The Tenco wide-wing system transforms highway snow removal with unmatched efficiency. Designed for heavy-duty operations, this oversized plow truck can clear up to 2 full lanes and a passing lane simultaneously, achieving a plowing width of up to 27 feet in a single pass. Its massive deployable wing allows operators to adapt quickly to changing road conditions, keeping highways clear during intense snow events. Equipped with advanced joystick controls, the system simplifies wing and plow operation, replacing older lever-action designs and reducing operator fatigue. The truck can also apply sand or salt while plowing, enhancing traction and road safety. Operators report that it performs in one trip what previously required 2 or 3 smaller units, making it ideal for maintaining critical routes during prolonged snowfalls. Built for high-capacity snow management, the wide-wing system ensures continuous progress on busy highways, preventing accumulation from overwhelming the roadway. With precise hydraulics, robust construction, and integrated material spreading, this turnkey solution delivers superior performance, reliability, and efficiency for modern snowplow operations.